Okay, the first part of the lesson that we missed today due to me being sick is that we need to finish section 3.1, rectangular coordinate systems. I had done a pre-video on this where we learned about plotting points again, and we learned the distance formula and the midpoint formula, and we needed to do a few more examples of both of those. So if you look down at example 2, we're going to be doing the midpoint and distance formula for both of these. So starting with the first one here, we're trying to find the distance between A and B, and then we're also going to do the midpoint. So remember, the distance formula is that you take the square root of, you subtract the x's, and then square that, plus you subtract the y's, and then square that. It doesn't matter if you write x1 minus x2 or y1 minus y2 versus x2 minus x1, just be consistent. So notice I started with the x1 and the y1 first in both parentheses. So this would be square root of 6 minus 6 squared plus 2 minus negative 2 squared. So that's going to change to plus plus. Square root of, let's see, this would be 0 squared plus 4 squared. And that gives me 0 plus 16, which is 16. So square root of 16 is 4. So this one actually comes out to a nice number. That doesn't usually happen, but sometimes it does. And then the midpoint formula, we do capital M, and we take the midpoint by adding the x's and then cutting it in half, so taking an average, and then adding the y's and cut them in half. It is important that you do x's first because this is an ordered pair. So this would be 12 over 2, comma 0 over 2, which gives me the ordered pair 6, comma 0. That would be my midpoint. Okay, let's do another one of these. C is the final one asking for the distance and the midpoint. So when we look at C, let's do the distance formula first. So I'm just looking up here to reference my formula. So this is negative 4 minus 0, because that's my x's, squared, plus, because remember it's a squared plus b squared. So this is 7 minus negative 8 squared, which will change to plus plus. So in this case, we get a negative 4 squared plus a 15 squared. Negative 4 times negative 4 is positive 16. 15 times 15 is 225. Double check myself there. So that would be plus 16 is 241. Now that is not a perfect square, but we do need to check and see if it's divisible by anything. So I divided it by 3. That didn't go. 4 is not going to go. 5 doesn't go. 6. Nope. Does 7 go into it? Nope. 8 shouldn't go. We'll double check. Nine doesn't go. 10 doesn't go. 11. Nope. 12 shouldn't go. 13 possibly. Nope. And we're almost to the end because notice the gap is getting smaller and smaller. And let's see, 14, 15 shouldn't go. What about 16? Nope. And we're pretty much at the end. So what I'm dividing by is actually giving bigger than the answer that we're getting. So we know that this doesn't break down into any factors, and therefore there's no perfect squares inside. So we would just leave it like this. If they say they want an exact answer, you do not turn it into a decimal. You leave it as a reduced radical. If they want you to go to decimal, it'll say approximate. So then for midpoint here, this would be negative 4 plus 0 cut in half, comma 7 plus negative 8 cut in half, because remember you add them and cut them in half. So that would be negative 1 over 2. So this time the midpoint is negative 2, comma negative 1/2. So there is how you find distance and midpoint. You do have to have those memorized for the exam. You have to know both of those formulas. Okay, the last two examples in section 3.1, and then we'll be able to do 3.2, is an application of the distance formula. It says find all the points on the x-axis that are a distance of 5 from a point -2, 4. I find that to understand what you're doing here, it's better to draw a picture. So if you imagine, here's the x-axis and the y-axis, and here's the point -2, 4. So there's P. We're asking if I was to, and it's not going to be straight down. I'll tell you why I know this. If you go straight down, that's a distance of 4 because it's 4 places up. So we can't go straight down to reach a distance of 5. So if I go this way, somewhere there should be a place where this equals 5, which means there's also probably a place that happens on the other side. So notice I could draw down to the x-axis 2 different ways and equal 5. So what I'm looking for is what we call a generic point. It's an x, 0. It's an x-intercept. So what we know is that we have a point that's set. It's -2, 4. We have an arbitrary point, which is, it's an x-intercept. I'm not really sure what the x value is. In fact, there's probably 2 possible x values. And I know that the distance between those 2 points has to be 5. So we're going to, and I'm calling these arbitrary points Q1 and Q2. So we're going to find the distance between P and Q, where we're going to actually solve for both of these at the same time. And we know that that would be square root of x1 minus x2 squared plus y1 minus y1, or y2 squared. See, I'm trying to say it the other way. And like I said, it doesn't matter as long as you're consistent. This time we actually know our distance, so 5 is going in over here on the left. For the x's, just be careful. If it was me, I would always write the variable part first. So we're going to go from Q to P. So x minus -2 squared plus, the second guy starts with a 0, so that would be 0 for y, oops, just ignore that little guy right there, minus 4 squared. So this would be 5 equals the square root of x plus 2 squared plus -4 squared, which is 16. Now, before trying to do a bunch of foiling out inside here, you can solve this a lot quicker if you get rid of the square root. So to get rid of the square root, I'm going to raise both sides to the second power. So this would be 25, and then because this is one big radical, that would all just cancel out and leave me with what's inside. The next step would be to subtract the 16 over. So this would be borrow, that's going to be 9. Should have been able to do that in my head, sorry. And this is x plus 2 squared. And then this is just kind of like completing the square, the final step. We need to take a square root of both sides. When you do that, though, remember you have to throw on the plus or minus, which is how we're going to get 2 different ordered pairs. So plus or minus 3 equals x plus 2. I would subtract that 2 over. So I get -2 plus or minus 3. Now, because these are actual numbers, we can work that out. -2 plus 3 is 1. -2 minus 3 is -5. So my 2 points, Q1 is going to be the one that's the smaller one, so -5, 0. And Q2 is 1, 0. So they're kind of almost where I drew them, but that was just coincidence. Okay? So this is, again, just using the distance formula, but it's an application. All right, so we're going to do one more of these, and then that'll finish up the 3.1 part. It says, this is supposed to say find. That's a typo right there. Find all the points on the y-axis that are a distance of 6 from point P is 5, 3. Okay, so this time, and again, you don't have to draw the picture, but it helps me to orient what I'm doing. So this is 5 up 3, so there's P. This time I'm not drawing to the x-axis, I'm drawing to the y-axis. So somewhere I should be able to draw these dashed lines, and the dashed lines should have a distance of 6. So again, we're going to have a Q1 and a Q2, except this time these are not x-intercepts, they are y-intercepts. So the point would be not x0, but 0y. Notice we're orienting a different way. So 0y and 0y. So we're going to use the same philosophy, but we're going to be able to solve for both y's at the same time. So distance would be 6 equals the square root. I'm going to start with, I always start with the Q points because it makes this look a little bit neater. So this would be 0 minus 5 squared, because that's the x's, plus y minus 3 squared. Work out at least the negative 5 squared, that's 25, and leave the other part alone for just right now. If we square both sides, that'll get rid of that square root. That makes this 36 equals the square root, or excuse me, no, I already got rid of my square root. And I don't know if it'll let me go back. Sorry, my tablet is having a little bit of issues with the colors, and the erasers and stuff aren't working. So it's hard to back up and erase, so I'll just rewrite. 36 equals 25 plus y minus 3 squared. Okay, we'll subtract over the 25, which would give me 11 this time. Take a square root, but remember to put the plus or minus on the side with the number. That's how we're going to get our two different solutions. So I have plus or minus the square root of 11 equals y minus 3, and I will add 3 over to finish this. Now notice, this time we did not get a nice answer. You can't take the square root of 11 without turning it into a decimal, and we don't want that. So our ordered pairs are actually going to have the radical in them, and that's okay. So this would be 0, comma, let's write the bigger one, so 3 plus the square root of 11, since that is Q1 is higher than Q2 the way I've drawn it. And Q2 is 0 and then 3 minus the square root of 11. So there are my 2 points. Now if I wanted to get a decimal approximation for these, I could. That's going to be bigger than 3 but smaller than 4, because square root of 9 is 3 and square root of 16 is 4. So this is going to be about 6 point something, and then this would be 3 minus 3 point something, so this is going to be about negative point something. So I've actually drawn my triangle a little bit wider this time than it would be. But again, I just draw the picture to help me frame up what my points are going to be called. And that is the end of 3.1. You need to also now watch the 3.2 video.